starting the video. All right, so here we go. Today you are going to learn something about sequences of numbers. Like 2, 4, 6, 8, you know the next one's going to be 10. Super easy, right? But there's a way to write these in what's called a recursive formula. All right, so I'm not going to do 2, 4, 6, 8. Seems kind of insulting. So I'm going to do 3, and then I'm going to not tell you what I did, but I'm going to get to 9, and you might be like, I know what you did, but you don't really know what I did, because I could have done 2 different things to get to 9. Do you get what I mean by that? I could have added what? 6, or I could have multiplied by 3, and you can't tell until I give you the third number. But as soon as I give you the third number and I say it's 27, now you know what I did, right? All right, and if you know what I did, then how would I get the next number? Well, you times by what? Times by 3. All right, so please write this down. This is your first sequence. And then I'm going to show you how you write the formulas for these, because the formulas are what's weird and complicated. You all understand times by 3, times by 3. That's easy. All right, next thing, there's a few kids that tend to just, in their last class, they just were able to just stare at the board and listen to the teacher. You know how much you're going to remember from that? 10%. You'll remember 10% of what the teacher teaches. So if you actually write this and you actually take a few notes, it will make a huge difference on your success in here. Do you want to remember 10% of what I teach you, or like 70 or 80%? Because if you, as soon as you write, it activates a different part of your brain, and that part of your brain has a better memory. If you just stay and listen, you have an auditory memory, and that's about 10% of what you heard. All right, so please do write this down. And if you don't, I will come back and hassle you about it because it's important. All right, next thing. I'm going to say U1 equals 3. Write that down. I know you don't know what it means yet, but I'll explain it in a minute. That's like the first term. What do you think the 9 is? U2. What do you think the 27 is? U3. Good. See, this one is U1. This one's U2. This is U3. And when I say sub, do you get that that would be short for subscript? So when I say U sub 1, I mean U subscript 1, but it's a lot faster to say U sub 1. And it's S-U-B, not S-U-F. A lot of people are like, are you saying self? No, U sub 1, U sub 2, and U sub 3. And of course, if I keep going, it's going to be U sub 4, U sub 5, U sub 6, etc. All right. Now, what if we were in a term and we didn't know which one it was? Like, I don't know how this sequence started, but I ended up with 10, and then 15, and then 20. You might have assumed that I started with 0, but I could have started with -5. I could have started with -25. Do you get what I'm saying? If I don't know what term I'm at, then I call that U sub, I don't know. So I say U sub n. Take a second and write that down. Because the key elements of this formula are U sub n and the term right in front of that, which is U sub, well, I didn't know the first one, so what if I just say U sub n again? No, that would mean that they're the same, and they're clearly not the same. U sub n minus 1. Do you get whatever the n was? This term would be n minus 1. All right. Now, maybe you'll understand this sequence a little better when I say U sub 1 equals 3. That's saying the first term is 3. U sub n equals U sub n minus 1. What was that again? This was any random term, and this is the term in front of it. And then for my sequence, I was timesing by 3, so I'm going to say times 3. That's how we're going to tell you your sequences. It's not going to be as easy as saying 3, 9, 27. It's going to be U sub 1 is 3. It's like saying first term is 3. U sub n is given by U sub n minus 1, which is like saying any random term is given by the term in front of it times 3. See, it's just saying, take whatever number you have, times it by 3 to get the next number. All right. There's more to it, of course, but what I just told you is a really important part. So we're going to stop there and we're going to make sure you really got this. So if I change my sequence to be 5 times 2 is 10 times 2 is 20, ... What do you think my use of 1 is? Say it if you know it. 5. What do you think I'm going to write next down here? I know some of you know it. Yes, say it.
So n is equal to use of n minus 1
Perfect.
times 2.
Times 2. Perfect. All right. Do you get what he just did there? Do you understand that? See, that's taking a sequence of numbers and writing a recursive formula for it. If I had just started and slapped this up on the board, 0 kids would have known what is going on. So cool, I've just taught you something. I'm going to pause for a second because we have a visitor. Okay, so I've got our visitor taken care of here. So this formula here tells you these numbers here. So I'm going to try giving you a formula and seeing if you can give me the list like this. All right, u sub 1 equals 11. U sub n equals u sub n minus 1 plus 4. What are the first 3 terms? Now, in a minute, I'm going to ask you, did you get this or not? Like, I'll tell you what the answer is, and you'll tell me whether you got it or not. And I get it. It's mildly annoying to have to raise your hand. You don't have to raise it over your head. Literally just a half-raised hand that's just lifted off your desk a little bit means, yeah, I got it. Okay? And when I ask that, please take it seriously. Like, if you didn't get it, you didn't understand it, don't put your hand up. But if you did, please take the half second to just raise your hand halfway up to just be like, yep, I got it. Because then if I see almost everybody's got it, then I can move on. But sometimes I only get like 3 people got it. And then I'm like, oh, okay, so you're not getting this. See, because I can't tell right this second. I can't tell if you all know how to do this or if you're all lost. The only way I'll be able to tell is by asking you to raise your hand. So first level, I want you to check with that kid next to you. And if you don't get it, ask them how they did it. Maybe you'll get it then. Please, talk to that kid next to you.
So I just got my schedule like.
I get it. But I don't know if that's part of the process or not. So let me know if you're not in there, and I'll get you in there. Okay. For right now, you don't need to be, so. Okay, here we go. So the answers actually were 11, and then you add 4 is 15, and then you add 4 is 19. Raise your hand if you had that one. Just a halfway up is fine. Okay, good. Thank you. I think you guys are getting it. Cool. Can I go backwards? Can I give you 10, 20, 40? And can you tell me the formula for that? See, that's the main thing for today. It's going back and forth between I give you the sequence, you write the formula, or I give you the formula and you write the numbers. Excellent. All right. This one I'm not going to have you check with that kid next to you. I won't do that every time. UN equals UN minus 1. Just by the way, that's always, that's a big word, always going to be in your answer. U1 isn't always going to be U1. But in this case, it's U1 equals 10. But just be aware that sometimes you won't actually start with 1. What other thing could you start with? Well, let me give you this example. If you were doing an experiment and I said we start the experiment at the current room temperature, which feels to me like it's about 73. A little warmer than normal, partially because I got a heater going back there because it was a really cold day. and those windows, the sun starts pouring in, so I think it's like 73. Do you get that I wouldn't start with time 1 is 73? I would start with time 0 is 73. That way, after 1 minute, do you get it's probably heating up in here just slightly? Just slightly, like in a few minutes, it might get to be warmer than it is. So at time 1, it might have gotten warmer than that. So my point is, we aren't always going to start with U1. Sometimes we will start with U0. Okay, so back to this. Always put that in there. And then say either plus or times. And in this case, what is it? It's times by what? 2. Now we got to start learning what that's called. That times 2 is called something. And the reason you care is because on the test they're going to say, what is the common ratio? That's this thing. Let's abbreviate it. C ratio. That is the common ratio. Now, why is it a ratio? Because if I took the 20 and divided it by the 10, notice it's the second one divided by the first one. That gives me the 2, which is the common ratio. See, it actually is a ratio. It's this one divided by this one. That's a common ratio. Okay, what if it was adding? What if I was adding 2 each time? That would be completely different. And so it's called something different. It's not called the common ratio. It's called the common difference. So I'm going to make you one like that. So leave this one. This is a good example. This one is called a geometric. Put that next to this one. This is called geometric. We'll ask you for, are they geometric or are they arithmetic? The kind where you multiply is geometric, and it's got something called the common ratio. Why do you have to write all this down? Because this is your notes. This is what you're going to refer back to when on the homework tonight. We're probably going to have some time in class. You'll get most of your homework done in class. But you go home tonight, and they're going to ask you, what's the common ratio? And you're like, I don't know what that is. You look back at this page, and you write, oh, C ratio. Oh, that's that number. That's the common ratio. All right, now we'll make one example like this for arithmetic. So arithmetic are the kind where you start with, let's say, 5, and you add something each time. Let's just keep it simple and add 2. 7, 9, ... Then would you please write the formula for this thing? Let's just start with u sub 1. Even though you can start with u sub 0, stick to u sub 1. Keep your life simple. It's day 1. Don't get fancy yet. U sub 1. And then there's a u sub n. Blah, blah, blah. Did you have u1 equals 5? Good. Did you have un equals un minus 1? And then add 5 each. No, not add 5. What do I add each time? 2. That is not called the common ratio because it's not this divided by this. 7 divided by 5 isn't 2. Would you agree that the difference between 7 and 5 is 2? So this is called the common difference. The common difference. So if they ask you for a common difference, they're saying, what's the difference between 5, 7, and 9? The difference is 2 each time. That's the common difference. All right. Now, there's one more thing. Again, I didn't feel like you were ready for it. It was too complicated to say at the beginning, but now I think you're ready to start writing something called the domain of the function. All right, so here's the answer for this one. The domain of this one would be n, which is this little tiny number here, needs to be greater than or equal to 2. Now, I'm going to explain it, but for right now, just write it. That is called the domain. When you write your answers on the test, you have to include the domain of the formula. And domains are basically saying, these are the things that will work. So what this is saying in code is the little n number, the only way this formula works is if the n number is 2 or bigger. Now, why? Because u sub 1 can't be figured out from the formula. See, u sub 1 has to be told to you. You have to be told what to start with. So moral of the story is, this formula only works for the second term or the third term or the fourth term or the fifth term. It can't figure out the first term. Do you get how this formula, just telling you this without all this, you wouldn't be able to tell what to start with, would you? You wouldn't be able to tell U1. That's what this is saying. Now, if that's too complicated, you don't understand what I just said, then just always add an n is greater than or equal to, and you always make it 1 bigger than whatever this number was. If you started with a 1, then this will be a 2. If you start this with a 0, which you can, then this would be n is greater than 1. It'll always just be 1 bigger than the number you started with. Now, I know, that's a lot. You think the test on this is tomorrow? Of course not. You got a whole week to learn all this stuff. In fact, more like 2 weeks. This is just day 1. And again, there's a ton of new info on the first day here. That's a little rough. All right, so here's a culminating question. And you'll either understand it all, or you won't understand some of it. Maybe you'll understand some, but not all. And you're going to talk to that kid next to you in a second after you answer this and see which parts you agree on, and maybe you need to learn something from them. If I started with 2, and then I ended up with 3.5, can you tell yet whether this is geometric or arithmetic? No. You might suspect that I added 1.5, but couldn't I have multiplied by something to get it to grow to that? Yeah, I could have, and you can't tell. But as soon as I tell you that this one has a common difference, now you know for sure what I did. And you'd be able to tell me the next number. What is the common difference? You should be able to tell me that too. Take a second and just answer those 2 little questions. If you get what the common difference is, put it here. And then if you know what the common difference is, you can calculate what that must be. All right. Please write those down and then talk to that kid next to you. That's the reason I had you learn their names, so you get familiar with them a little bit, so you can feel free to talk to them and get answers. All right, I'm going to pause for a second while you talk to that kid next to you about those 2 answers. Let's see if you and I are on the same wavelength. Common difference means that you're adding something each time. And so then I must have added 1.5. So then if I add another 1.5, wouldn't this come up to 5? Raise your hand if you had the same thing as me. Okay, good. And then the common difference is 1.5. Cool. Now, can you write the equation for this starting with u sub 1? What's the equation for this again? U sub 1 equals blah. And then there's always that thing with the n in it. Show me. Show him. U sub 1 equals 2. And now, since this is adding 1.5, you always just go plus 1.5. Now, spoiler alert, you're going to see some where they do this, and I want you to not freak out when the time comes. Do you get if I add 1.5 at the end, I could have also added 1.5 at the beginning. Do you get that would do the same thing? Okay, good. So there's my little formula, except it doesn't have a domain. Take a second and write the domain. You don't have to understand the domain. I'd love it if you did. You just have to write n is something. What was that domain again? Talk to the kid next to you. What do they think the domain is? N is greater than or equal to 2. Why 2? Because this formula will only figure out the second term or bigger. It can't figure out the first term. That's why it isn't 1, it's 2. All right, there you go. Now, could you have told me whether this was arithmetic or geometric? It's either an A or it's a G. Please write that somewhere near this formula. It's either A or it's a G. How many of you are feeling A on this one? Raise your hand for A. You are correct. It is an A. Arithmetic is the kind that has a common difference. Do you remember if this had been geometric, then it wouldn't have been a common difference. It would have been a common what? Ratio. Very good. So back here, common difference. We added something each time. We, again, did an adding one. So it was arithmetic and it was a common difference. Last one I'll do with you is going to be the kind where you multiply by something. And it won't be a common difference. It'll be a common what? Ratio. Good. All right, this one's going to feel weird. 4 times something makes it equal 6. I didn't add 2. I timed by something. Using a calculator, which most of you, I am thinking, already use your iPad's calculator for this, figure out what I multiplied by, because that's the common ratio. I will warn you, if you take 4 divided by 6, that will not work. I'm telling you it's a common ratio, so you know that you multiply by something. But to get that number, you have to do a ratio of 6 divided by 4. And if you do that on a calculator, it'd be like 3 divided by 2, which you probably could do in your head. It's a 1.5. I'm not adding 1.5, I'm multiplying by 1.5. So that's the common ratio. How many of you had 1.5? Just give me a quick hand. Oh, good, a lot of you had that. That's awesome. And then you'd know that you'd take 6 times 1.5. Now, some kids can do this in their head. And some kids will need a calculator. Either way is fine. Talk to that kid next to you. What's that next number? 9 is correct. Very good. 6. And basically take half a 6 and then you add that to the 6 and you got 9. It would be times 1.5. All right, good. And then what's the formula for this? UN equals UN minus 1. But what goes before that? U1. All right. Now don't freak out when they start saying U sub 0. It's going to look exactly the same. It's just that on the first few that we do, we always start with U sub 1. And U sub 1 equaled 4. And U sub n minus 1 times 1.5. You can either put the times 1.5 here, or you could have put the times 1.5 in the front. Either way would have been fine. All right. And just curious, how many of you remembered to put n greater than or equal to 2? Who remembered that before I said it? Thanks for being honest. That was only like 5 of you. That's going to happen on the test. So easy to forget that domain, and we will have to mark it wrong. It's a critical part of the formula. So include this little dude. And if you're like, I don't get what that is, it's okay. I'll explain it to you again later. But for now, just put n greater than or equal to every single time, and it'll always be 1 bigger than that. All right, now let me just show you one where it starts with U sub 0. It's just the same exact thing. Don't have to write this down. This is weird, but just listen. What does this one start with? 5. It's just saying to start with 5. And what do you do each time? You add 8. It's the same thing. So it's just that when you're done and you add 8 to the 5, Mr. Server, what is 8 plus 5? 13, thank you. And then I add 8 again, 21. Then this guy's name isn't U1, it's U0. And this is U1, and this is U2. Do you get what I'm saying? You can start with U sub 0 if you want.
N is greater than or equal to 1.
Very good. And the formula has a domain of n is greater than or equal to 1 because it'll be 1 bigger than this. And this formula, you can figure out the first term, but you can't figure out the 0 term. You can't tell what to start with. So it's always 1 bigger than this. All right, cool. You've now learned everything. Now let me explain how I do Schoology quizzes. In some of your teachers' classes, you had unlimited tries, but the downside to that is you didn't know what, you knew which ones were wrong, but you didn't know why they were wrong or what the right answers were. In my class, I give you the answers after your first try, but the downside to that is you now know all the right answers. So if I give you unlimited tries, you're going to get 100% every single time. So I think the reasonable compromise is try. It's okay if you get a few wrong. If after you get a few wrong and you get, let's say you get a 7 out of 10, and you're like, I really would rather have a 9 out of 10. Well, you just can take it again after you've seen the answers, and of course you're gonna have 100% the second time. See what I mean? Then you'll get an average of those two scores. Why don't you get the second score? Because you'll always get 100% on every single homework assignment without even knowing what you're doing, because you just copy the answers down. So if you want to do the extra work of going through and doing it twice, you'll get the average of your two scores. Most kids just do it once, and they get a score of like 7, and they're fine with that, because they know the homework is only worth 10% of your grade. And 7 points out of 10 is worth way more than 0 out of 10 for not doing your homework. So do it at least once. If you're an overachiever, you'll know what the answers are, and you can do it twice. All right, there, you made it through the first day of math. Congratulations. That's all I got for you for today.